Okay, so you guys have had a chance to work on this. What did this conversion factor turn out to be? Remember what the idea is. You're given, this is for the recording, guys. You're given that the truck has a tire of radius 45 centimeters, and it's rotating at 500 RPM. So that's the way I'm going to represent this 500 RPM as a ratio. 500 revolutions per division bar means per 1 minute. And then you've got to multiply by a conversion factor. You ultimately want the answer in kilometers per hour. You want to know how fast the truck is going, right? So you want the answer in kilometers per hour. So let's start by converting the revolutions to a distance measurement. That's something I can do, because I know if I know that the tire is rotating at 500 revolutions per minute, I can figure out how long or how far the truck travels per 1 revolution, because I know the circumference of the tire when I'm given the radius. So the formula for the circumference, 2 pi r. What did you fill in for r? So you filled in the radius of 45. So 2 pi times 45, or 90 times pi, either one works. So is everybody comfortable with that conversion factor? 2 pi, 45 centimeters. So there's 1 circumference per 1 revolution is essentially what we're saying with this conversion factor. So we multiply by that conversion factor in red. Is everybody okay with that? Now do a quick check on your units. If you do the analysis here, the revolutions cancels with the revolutions here. You're in centimeter. If you stop here, you're in centimeters per minute. Not what you want, but at least you're in the right, well, you can't see this in the video. At least you're in the right ballpark in terms of linear units over time units, right? Centimeters is linear, and minutes is time. So we're on the right track. Okay, so what's the next conversion factor going to look like? Well, we're going to have to do a couple of things. We're going to have to convert eventually centimeters to kilometers and minutes to hours. So, you know, it's a matter of opinion or just taste as to what you do first. Doesn't matter. So, okay, so let's convert centimeters to kilometers. So how do I do that? With a little bit of thought, you'll realize since there's 100 centimeters in a meter and 1,000 meters in a kilometer, you can figure out by multiplication how many centimeters are in 1 kilometer. What does it turn out to be? 100,000, right? So you get your next conversion factor. You want to get rid of centimeters, so where does that have to be? Denominator. You want them to cancel. And you want kilometers to appear, right? So you can do that as long as you realize that there's 100,000 centimeters, I'll put that down here, per 1 kilometer. Does that make sense to you? So that's your conversion factor, 1 kilometer per 100,000 centimeters. Does that seem reasonable? Okay, now you've got the bottom numbers, the bottom units, minutes, right? You want to put it in hours, so what do? You want to get rid of the minutes in the denominator, so what do you multiply by on top? What kind of units? Minutes on top. You want, if you go back over here, you want hours, hour units in the denominator, so minutes over hours, and then you just know what you've known since you were, you write down rather what you've known since you were, I don't know, 6 years old. How many minutes in an hour? 60 minutes per 1 hour. Everybody agree with that? Okay. So let's do the analysis. Unit analysis. We've already canceled out the revolutions. We're good there. The centimeters cancel. The minutes cancel, right? So what units are we left with? Kilometers per hour. So we're pretty sure we did it right, aren't we? As long as we can get through the arithmetic here. So this is where you break out your calculator. And what I need you to do, so help me out here, probably the easiest way to do this on your calculator is to go ahead and do the numerators first, straight across. Take the 500, I'm going to write this as 90 pi, times 90 pi times 60, that's what would go on top, right? If you want to plug it in all at once in your calculator, then you have to be careful. If you don't use parentheses, well, okay, in this case you don't have to be too careful because the only number that's not 1 in the denominator is this 100,000, right? So divide by 100,000 if you do that sort of operation. So on top 500 times 90 times pi times 60 on top, and then divided by 100,000, it should get you where you want to go. But if you had more than one factor in the denominator, like let's say you broke it up into 100 times 1,000, you'd want to put parentheses around the product in the denominator to make sure your calculator doesn't divide by 100 and then multiply by 1,000. So be careful with that. In this one, since there's only one number, it doesn't matter. And then that will be in kilometers per hour. Could you run that through your calculator and get an? I just wanted, for this problem, I just wanted an approximation, not an exact answer. So approximately 84.8. Is that what we're all getting? I believe that's what I got too. I just didn't bring my notes today. Okay. So there you go. 84.8 kilometers per hour. So you know how fast the wheel is spinning as an angular velocity. You can figure out the speed in kilometers per hour. Any questions? Okay. So that'll do it for now.